In this video, let's go ahead and practice solving some consecutive even and odd integers word problems together. In this first example, we're going to go ahead and find three consecutive even integers such that the sum of the smallest number and twice the middle number is going to be 20 more than the largest number. Let's start by just focusing on the fact that we have three consecutive even integers. To help get us started, we're going to have to see if we can write some algebraic expressions to represent these even numbers. So let's go ahead and define a few things here. So let's let a few different things represent these first, second, and third integers. Now, to guarantee that an expression or number is going to be even, you have to go ahead and double it, right? So for the first even number, I'm going to go ahead and say that that is going to be 2n. Right? So no matter what n is, if you multiply by 2, it's guaranteed to be an even number, right? Now, even numbers are always 2 away from each other, so if that first number is going to be 2n, then the next even number must be 2n plus 2 if it's going to be larger than it, right? And the next even number that's going to be after that is going to be 2 more than that, so we could write 2n plus 2 plus 2, or we can write 2n plus 4. So just say we said that n was equal to maybe 7 for a moment, right? If n was 7, then 2n would be 14, then 2n plus 2 would be 16, then 2n plus 4 would be 18, and these would be three consecutive even integers. Or even if we said something like n was equal to 5, right? Then this 2 times 5 would be 10, and 2 times 5 plus 2 would be 12, and then 2 times 5 plus 4 would be 14. And just for good measure, let's just say that n was equal to 6, right? So 2 times 6 would be 12, 2 times 6 plus 2 would be 14, and 2 times 6 plus 4 would be 16. So you can see that no matter what n is going to be, we're going to have even numbers here. All right, next it says that we are going to be taking the sum of something. So sum means we are going to be adding some things together. It says we're going to be adding together the smallest number. So what's the smallest number here? Must be this 2n. So let's go ahead and start by writing that. We're going to have 2n, that's the smallest number, and we're going to be adding what to it? We're told that we're going to be adding twice the middle number. So we're going to be adding the smallest number, which is 2n, and then twice the middle number. So the middle number is this 2n plus 2. So we're going to add twice this. So it's going to be 2 times the quantity of this 2n plus 2. Then we see the word is here, and the word is just means that that's an equal sign, okay? So let's go ahead and write that equal sign. And the last information they tell us is that it's going to be 20 more than the largest number. So this 2n plus 4 is going to be our largest even number, so 2n plus 4, and it says it's going to be 20 more than that, so we're adding 20 onto this. All right, so this is going to be the equation that we're going to solve here. First thing I'm going to do on the left side is distribute this 2 to both terms inside here. If we do that, then we're going to have this 2n plus 4n plus 4. And then on the right side, let's go ahead and just combine these like terms of 4 and 20. So we're going to have this 2n plus 24. On the left side, we can also combine these like terms of 2n plus 4n. So we're going to go ahead and write 6n plus 4 is going to be equal to this 2n plus 24. Alrighty, so now we're going to go ahead and just kind of move some things left and right here. So on the next step, we're going to go ahead and take away 2n and take away 2n. I just want all my n's to be on the same side on the left side. And from that, we're going to get 4n plus 4 is equal to 24. Then we're going to go ahead and take away 4 from both sides. And we find out that 4n is going to be equal to 20. And then finally, we're going to divide both sides by 4. And we find out that n is going to be equal to 5. All right, cool. So now we know that n is equal to 5. We can go ahead and plug that in over here. So 2 times 5 would be 10 for the first even integer. Then for the second one, it's going to be 2 times 5, which is 10 plus 2 is 12. And over here, we're going to get 2 times 5, which is 10 plus 4, which is 14. All right, so in conclusion, we can say our first even integer is going to be 10, the second one is going to be 12, and the third one is going to be 14. All right, let's try another one together, but this time, let's talk about consecutive odd integers. So in this one, we're talking about finding three consecutive odd integers such that the sum of 7 times the smallest and twice the largest is equal to negative 91. All right, so let's just start by getting organized and define a few expressions here. So let's go ahead and see, what are we going to write to express each of these odd numbers? Now, in the last example, we knew that even numbers can always be guaranteed if we double an integer. So odd numbers are always one away from even numbers. So for this first odd number, what I'm going to go ahead and write is I'm going to write 2n plus 1. Right? So any even number plus 1 is an odd number. Now odd numbers are always 2 away from each other, so we can write for the second odd integer, this is going to be 2n plus 1 plus 2 or plus 3, right? They have to be 2 away from each other, so we're going to add 2 more to this one. For the third integer, that's going to be 2n plus that 3, but then add 2 more onto that, so it's going to be plus 5, because that has to be 2 away from it, right? Now, just to see if this makes sense real quick, let's just say n is hypothetically equal to 4, right? If n was 4, then this would be equal to 9, and this would be equal to 11, and this would be equal to 13. So these are consecutive odd integers, right? Or let's just say n is equal to 9. If n was 9, this would be equal to 19. This would be equal to 21, and this would be equal to 23. So you can hopefully see that no matter what we say for n, we're going to get 3 consecutive odd integers. All right, now that we know what expressions we're going to use for our first, second, and third odd integers, let's look at the rest of the problem. Now, they give us this key word in here of sum, which means we're going to be adding some things together here. But what are we going to be adding? Looks like we're going to be adding 7 times the smallest. And so this right here is our smallest integer. So let's go ahead and write 7 multiplied by that. So it's 7 times the quantity of this 2n plus 1. And what are we adding onto this? And so we're going to find the sum of that with what? It looks like it's going to be twice the largest number. So what's the largest number? Out of the 3 expressions, this 2n plus 5 has got to be the largest one here. So it's going to be twice that. So it's going to be 2 times that quantity of 2n plus 5. Then we see this keyword of is again. Remember, is just means equal. And so this whole thing is going to be equal to negative 91. So I'm just going to go ahead and write that equals negative 91. All right, so we have our equation here. Let's go ahead and solve it. I'm going to start by distributing the 7 to both of these terms over here. 7 times 2n is going to be 14n, and 7 times 1 is going to be 7. And then what are we going to have after that? Looks like we can go ahead and distribute this 2 to this 2n and this 2 to this 5. So 2 times 2n is going to be 4n, and then 2 times 5 is going to be 10. All right, this whole thing is going to equal negative 91. Next, if we combine some like terms, this 14n plus 4n, that's going to be a total of 18n. And then next, we can also combine these other like terms. We have this plus 7 and plus 10, those constants. That's going to be plus 17. Combining those, we're going to get equal to negative 91. And at this point, we just have a 2-step equation, right? So on both sides of the equation, let's go ahead and subtract 17 on both sides. When we do that, those 17s are going to cancel out on the left side and make 0. On the right side, we're going to get negative 108. And then finally, we're going to go ahead and divide both sides by 18 here. Dividing both sides by 18, we're going to find out that n is equal to negative 6. All right, now that we know what n is equal to, we can find out each of these odd integers. First, we can substitute this negative 6 in here. 2 times negative 6 is negative 12, plus 1 is negative 11. Then plug it in over here. 2 times negative 6 is negative 12, plus 3 is negative 9. And then finally, 2 times negative 6 is negative 12, plus 5 is negative 7. And so just kind of wrapping this all up together, we said that first one was negative 11. The second one ended up being negative 9. And the third one, which is the largest one of the 3, ended up being negative 7, and these are consecutive odd integers. And real quick, if you just wanted to check this, it says the sum of 7 times the smallest and twice the largest is supposed to be negative 91. So 7 times the smallest, if you multiply this one by 7, that's going to be negative 77. Twice the largest, if you go ahead and double this, that's going to be equal to negative 14. And so if you go ahead and add this negative 77 and negative 14, the sum of those, you do get negative 91. So hopefully that makes sense. So there you have 2 different examples of working with some consecutive even integers as well as some consecutive odd integers. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.